So, good morning, good afternoon, or good evening, everyone. I am Emmanuel Chavez of BIT-IK2 Drafting, presenting you Multimeter Scale Interpretation and Calibration. So, let's start off with a very inspiring quote by Gagamboy. With great power comes great electricity bill. Well, it's true. That's why we have to, conserve energy to save our Earth, Mother Earth. Anyway, so for our learning objectives, at the end of the presentation, the audience is able to understand the concept of multimeter scale, proper multimeter scale interpretation, and calibrate an analog multimeter. So let's first talk about multimeter scale interpretation. What is a multimeter scale? Well, it is found on analog type multimeters. The scale serves as the screen to show the ohms, current, and voltage value being measured. Two types of multimeter: analog multimeter and digital multimeter. But the settings somehow differs on the brand or the unit that you have. Next, parts of a multimeter scale. So at this picture, you can see the very detailed parts of a meter scale, but the usually used scales in multimeter is the ohm meter, voltmeter, and ammeter. So the ohm meter scale is the one that has the omega symbol, this guy. So this is the ohm meter scale. So it is used to measure the value of resistance. Next, the voltmeter scale, or the DCVA and ACV, this one. So this is the scale, the voltmeter. So it is used to measure the value of moderate to high number voltages, while underneath the AC 10 volts, which is this guy, this is for 10 volts and less voltage number measurements. But voltmeter scale is also used as ammeter to measure the voltage ampere by selecting proper range. So talking about proper range, multimeter scale reading. So as you can see at this picture, this is the one that I talk about, the proper range. So this is the range selector. So let's first talk about this one for us to understand. So the ACV is for measuring the voltage of an alternating current. So the best example of this is our outlets at home. So they uses alternate currents. Next is this guy, the DCV, which means direct current voltage. So it is used for measuring voltage of a direct current. Example are batteries and more. Also this DCMA. So this is used for small types of voltage, milliampere. So lastly is the ohm range. So this ohm range is used to measure the resistance of a material. That. So we already know the purpose of this, or the uses of the selector range. So here this table, as we can see, these are the conversions of numbers on reading the multimeter scale. So next here, so this is the multimeter scale, right? Then this is our table. So let's say we're going to pick a range. So like what I said a while ago, the range setting, these are the range settings. Example 0.25, so this would be the 0.25, then 0.5 would be here, 0.5, 2.5, so on and so forth. These guys, 10, 50, 250, and 1000. So these are the guys, 10, 50, 250, and 1000. So to get our reading, the proper reading, let's say we're going to use the 2.5 DCV range setting. which is this 2.5. 2 point, I mean sorry, 0.25. This 0.25 or this guy. So we're going to use that, and our convert and then our conversion will be 0.005, and the scale that we're going to use is 0 to 250, which is this. How this 0 to 250, and the numbers we will going to convert it by 3 decimals. So this will be 1, 2, 3. So this will be 0 0.250, 0 0.05, then 0.1. So that's it. Then these lines will count as 0.005. Example, 0.0, then 0, then 0.005, 0.010, 0.015, then 0.020, then 0.025, then this will be 0.050, then 0.1, and so on and so forth. The next example is this guy, the 10 dCV slash ACV. So we can use there this guy, 10 ACV or 10 dCV. So to convert it, the numbers that we're going to use will be the 0 to 10 scale, which is this guy, 0 to 10. Then we're going to convert it by 0.2. So these lines, the measurement of these lines will be 0.2. For example, 0, 0.2, 0.4, 0.6, 0.8, 0.1, then 0.1. No, I mean 1. The next is 1.2, 1.4, 1.6, 1.8, and 2, and so on and so forth. So that's that's the what do you call that? The conversion of it. Next, let's talk about the multimeter scale calibration. So here, before we start on calibration, we have to prepare first and familiarize the parts of analog multimeter that we're going to use. So here is the multimeter scale. So it is very important, for it serves as the screen to determine if it's already calibrated. Second, the pointer, which determines the accuracy of calibration. So third, selector knob, the one that I discussed earlier. So this is very important. This is used to select range that you want to calibrate. So the range, this is the range. This is the times 1, times 100, times 1K, and so on and so forth. So that's the ohm range. So next, 4, test probes. The input part of the multimeter. The red probe is for positive terminal and black is for ground / negative terminal. Next is the 0 ohm adjuster. So it is a circular knob used to adjust when the pointer is not pointing to 0. So now we are familiar on the things that we're going to use on a multimeter to calibrate it. So this is the calibration procedures. First, set the multimeter to its ohm meter function, which is located to the lower right portion of the selector knob, which is this, as I have said earlier. The second, select which range you want to calibrate. So whether it's times 1, times 10, times 100, times 1K. Excuse me. Third, short the positive and negative probes together, just like this. Then when the pointer is not pointed to exactly to the 0 ohms, then it needs to be calibrated. So as we can see here, it is not pointed to exactly 0, which is here. So we must calibrate it. So to calibrate it, use the circular knob to adjust the pointer. This. So when calibrating it, it must be exactly to 0, not too much or lesser, but exactly. So a reminder on calibrating. Every time switching to other ohm ranges, the same calibration procedure must apply. So here, example, we're going to change range from 1x from times 1 to times 100. So if we do that, then try to short the probes, the result here would be different. It won't be exactly to 0. That's why we need to uh, apply calibration every time we change ranges. Next, for digital multimeter calibration. So in digital multimeter calibration, it is often used another machine to properly calibrate it, and other brands or units has switch inside it for calibration. So that's what I have learned from researching, that the multimeter, digital multimeter, is somehow a bit more confusing to calibrate than the analog multimeter. Next, significance of calibrating. So why is it important to calibrate it? So analog type multimeter is required to calibrate every time before it's used, when digital, while digital variants often calibrated yearly. Quality measurements and processes depend on the continual proper operation of a multimeter. However, time, environment, and physical use or abuses cause to change multimeter's characteristics. That's why it's important to periodically calibrate or verify the performance of a multimeter. So it depends on how you use the multimeter, whether you use it frequently or sometimes you dropped it, then it will cause to change the multimeter state. So if that happens, maybe your multimeter is all that broken or has a weak battery, then it needs to be calibrated. That's that's what you need to do if you have some multimeter issues. So trivia time. In 1920, a British post officer, engineer Donald Macadie, is credited with inventing the very first multimeter. The story goes that he was frustrated that he needed to carry a bunch of different tools when working on telecom lines, so he created one tool that could measure amperes, volts, and ohms. So that's the history of multimeter. It's just because of frustration. But anyway, thanks to Donald Macadie, the they call that the modern era, the life of modern era became easier. So that's it for my presentation. So if you have any questions, you can find me at my house. Thank you very much. Goodbye.